we go over the nature and the roots of a quadratic equation. Now we know that the quadratic equation is in the form x squared plus bx plus c being equal to 0. Now if we want to have x squared having the coefficient of 1, we are going to divide everything by by a. And so what we are going to remain with is this x, and that is going to cancel. So we are going to have x squared plus b over a x and then plus c over a, that is going to be equal to 0. Now if we leave it at this point, let's say this is our first equation. Okay, so let's try to forget about this one for a bit. Now let's say when we are solving our quadratic equation, we found that x was equal to alpha or x was equal to beta. Remember, when you are solving a quadratic equation, you are going to find two values. You are going to find that x is equal to maybe 4 or x is equal to -2. Now just from these values you are able to tell where you came from. So that means for you to have these two values, you first add x minus 4 and then x plus 2 being equal to 0. So you can again multiply, that becomes x squared plus 2x minus 4x minus 8 being equal to 0. So that gives you x squared minus 2x minus 8 being equal to 0. So this is the equation that we had before we had these two solutions. So notice that when you have been just given the two solutions of the equation, you are able to determine the equation from which it came. So if you've been given that x is equal to alpha or x is equal to beta after solving, that means the equation which we had was x minus alpha, x minus beta, that being equal to 0. So at this point we can cross multiply. X by the other x in the other bracket becomes x squared, and then x by the negative beta becomes negative beta x, negative alpha, so this negative alpha by the x, that is going to give us negative alpha x, and then negative alpha times negative beta, that gives us positive alpha beta, and that is going to be equal to x. Now notice that we have got x there, we have got x there, so we can factorize out an x. We can also factorize out a -1. So we're going to have x squared, we are going to remove a -1, so we're going to remain with a beta here, and then that will be now a plus alpha. We've also removed an x outside there. So this we can also write as alpha plus beta instead of saying beta plus alpha. So let's say alpha plus beta, and then x outside, and then plus alpha beta, this being equal to 0. So this will be our second equation. Now notice that x squared is equal to x squared. That means that this number in front of x should be equal to this number in front of x, and then this constant should be equal to this constant. So that is giving us that we are going to get this negative alpha plus beta is going to be equal to the number there, which is b over a. Now if you want to do away with this negative, you can multiply everything by a -1. So this will give us now alpha plus beta being equal to negative b over a. So this is very important when you're determining the roots of a quadratic. And then the constant should be equal to the other constant. So that means the alpha beta should be equal to c over a. So that is also very important for us to understand. Okay, so what we are saying is, if we've been given two roots, as you saw, x was equal to alpha or x was equal to beta, we are able to determine either the equation or the value of alpha plus beta and alpha times beta just by looking at the roots. So what you can see is, at this point we have added the roots, at this point we have multiplied the roots. So an equation of a quadratic function is given by x squared minus sum of the roots x, and then plus product of the roots, and that being equal to 0. So that is how we determine the equation of a quadratic function using this equation which is here, which has just come from what we can see at this point. So let's keep these in mind, because these are so useful even as we'll be doing some questions. Now again, if we remember, of course, we know that the general form of a quadratic equation is x squared plus bx plus c being equal to 0. So if you use the completion of squares, we're going to find that x is going to be equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So this is our quadratic formula. Now in this quadratic formula, this portion which is here in the root is called the discriminant. So this portion is going to determine the nature of the roots that we are going to have. Some kind of quadratic functions do not touch the x-axis. Others only touch the x-axis at one point. Others cut the x-axis at 2 points. And all that is determined by what we have here. So take for instance, okay, let me call now that this part, the b squared minus 4ac, that is called the discriminant. Alright, so our interest in b squared minus 4ac. So if this b squared is minus 4ac is greater than 0, that means this value is giving us a positive number. So that is going to mean that everything in the root, you are going to find a positive number there. Whenever you find a positive number in the root, that means when we are sketching, our graph can either be like this or it can be like that. The thing is, it's going to cut the x-axis at 2 points. And so the nature of roots for this one, then that equation has got 2 real, so okay, we have got 2 real distinct roots. They are not just real, but they are different roots. They are 2 and different. Now when we find that our b squared minus 4ac is equal to 0, that means our function has only cut the x-axis at 1 point, just in that manner. It can also just pass something like that. So it has just touched the x-axis at 1 point. Now notice that our value only be 1. In other words, the x-axis is only being cut at 1 point. So we are going to have the nature of this quadratic equation is going to be only 1 real roots. We also call those as 2 equal real roots. So if 2 roots are equal, then it's just the same thing. That is why we say 1 real root, because they are 2 equal. Alright, so what you are going to say is you are going to have from the formula negative b plus or minus the root of 0 and then over 2a. So that is how you are going to find your formula, because this portion has given you a 0. Now the root of 0 is simply a 0. So what you are going to find is negative b plus or minus 0 over 2a. So it will be negative b plus 0 or negative b minus 0, which are 2 equal roots. Alright. Now if you find something that is in the where you find that b squared minus 4ac is less than 0. Now if what is inside the root is less than 0, that means it's a negative number. Remember, only negative numbers are less than 0. That means we have got 2 complex roots. So what you are going to see is something like this. It can either pass like this, it's not cutting the x-axis at any point, or it can pass like that. As you can see, we are not cutting the x-axis. Then we are going to have 2 complex roots. Alright, so having understood this, we can look at some practice questions. So we've been given first question. Without solving the equations, determine the nature of the roots of the following equation. Now the first equation that we've been given is 4x squared plus 20x plus 25 being equal to 0. What will be the nature of roots of this equation? Now for us to determine the nature, remember we're not solving the equation, so for us to determine the nature is we need to determine the sign of b squared minus 4ac. So what is that going to give us? Now our b is this number here, so that will be 20 squared, and then minus 4, our a is the number in front of x squared, and then our c, which is a constant, that is the 25. Okay, now 20 squared is 400. If we multiply 4 by 4 by 25, of course 4 by 4 is 16, and then 16 by 25, that is going to also give us a 400. Now 400 minus 400 is a 0. Now we have simply found that b squared minus 4ac is equal to 0. When b squared minus 4ac gives us 0, then we have got one real root or two equal real roots. Those equal roots are real. So that's the nature of the first one. Now to determine the second one, we're going to use the same procedure. Okay, for the second one we have x squared plus 4x plus 7 being equal to 0. So we're going to determine b squared minus 4ac. Now our b in this case is 4, so we square it, and then minus 4. The number in front of x squared here is our a, that is 1, and then the constant, which is 7. So 4 squared is a 16, and then 4 by 7, that is a 28. So subtracting 28 from 16, we're going to get negative 12. Now notice that what we have is a negative number. A negative number is less than 0. So this is b squared minus 4ac. So what we've just determined is that b squared minus 4ac is less than 0 because it's a negative number. So because it's a negative number, that means this equation doesn't cut the x-axis. So we have got two complex roots. That becomes the nature of that equation. Okay. Now let's consider this one. Find the value of k, or the range of values of k in each case below. So for the first case that we've been given, the roots of, we've been given but 1, 3x squared minus 5x plus k is equal to 0. They've told us the roots differ by 2. So the roots differ by 2. Now what does it mean if the roots differ by 2? So that means that if one root, let's say when one root is I can use just n letter. If one root is beta, then the other root is going to be beta minus 2, or it can also be beta plus 2. Let me use plus 2, because whether plus 2 or minus 2, they all differ by 2. So this is what we have found. The roots differ by 2. So it can differ going up or going down. It doesn't matter which is which. So you can use any. It will be all the same value. Okay. Now for us to have these two roots, where do we come from? So that means it was x minus beta, and then x minus beta plus 2, that was equal to 0. So for us, the only way we can get these two roots is when it came from this point. Now at this point, if we can cross multiply, that is going to give us x squared. So we've multiplied this by that, and then x by that, we're going to get negative beta plus 2, and then x, and then this by this, that will be negative beta x, and then negative beta times that. So it is negative by negative, that will become now positive beta plus 2, and then the beta is going to be here, that is going to be 0. So I've just gotten this portion, and then I get the beta, which I've put here. Alright, so let me just try to clean up this space. So at this point, what we can do is, of course, we have got the x squared. Sorry, I just removed some value which could have. Alright, so like that. So this is our x squared, and then minus, I can expand this minus times beta, that will give you minus beta. Remember, there's also this x, so the minus beta x, again minus times 2, that would be minus 2, and then there is that x, and then minus beta x again, which is here. Again we have got a beta here, so we can expand beta times beta, that would be beta squared, and then 2 times beta, that would be 2b, and that is going, 2 beta, that is going to be equal to 0. Now we have got like terms here, so this is going to be x squared. Of course, we can add this and that to give us negative 2 beta x, and then you've got a minus 2x, and then plus beta squared plus 2 beta, and that is going to be equal to 0. So we can go on and write it there. That is going to give us x squared. Now these are two like terms. I can factorize out an x, and I can also remove a negative to the outside. So what I'm going to have is negative, and then inside we are going to remain with 2 beta plus just 2, and then I'm going to put the x outside there, and then we have got plus. Also this is a constant, as you can see there is no x, so I'm just going to put it together like b squared plus beta squared plus 2 beta is equal to 0. So put it like that. Now these two roots came from this equation which is here. We've been told the roots of the equation differ by 2. So what we are going to do is this real part. So I need to make sure that the x squared has got a coefficient of 1. So I'm going to divide this everything by 3. So that is going to give me x squared minus 5x over 3 plus k over 3 being equal to 0. That means the negative 5 over 3 should be equal to this portion, okay, because those have got the same coefficient. So I'm going to get negative 5 over 3, and I'm going to equate it to negative 2 beta plus 2. Now we see that the negatives can cancel out. So what I'm going to have is just 5 over 3 being equal to 2 beta plus 2. I can take to the other side, and then it will be 5 over 3 minus 2, which can give us 5 minus 6 over 3, which is a negative 1 over 3. So that is going to give us 2 beta. I've just started by writing this being equal to negative 1 over 3. Now for me to remain with only beta, I'm going to divide by a 2. That is going to give me beta is equal to negative 1 over 6. So that is the value for beta. Now for me to find the value for k, I'm going to get this part and equate it to this part. So that is going to give k over 3 being equal to beta squared plus 2 beta. But we know the value for beta, that's negative 1 over 6 squared, and then plus 2 times beta, which is negative 1 over 6 again. So that gives me negative 1 over 6 squared, that would be 1 over 36, and then minus, so 2 times negative 1 over 6, 2 there is 1, 2 there is a 3, so that would be negative 1 over 3. So at this point, if we subtract just 1 over 36 minus 1 over 3, we're supposed to get negative 11 over 36. So that is the value for k in this case. Okay, so that would not be the value for k because this was k over 3. So I'm going to say even here it is k over 3, even here it is k over 3. So what you have found is k over 3. Now for us to remain with only k, we're going to multiply everything. Since the 3 is down here, we'll simply multiply everything by 3. So notice that 3 can go into 36. And so our value for k is going to be negative 11 over 12 for the first portion. Alright, so that is how we determine the value for k in that one. So for the second one, which we have here, find the root. So we've been given the roots of the equation. So the equation we've been given for the second one is 3x squared plus k minus 1x minus 2 is equal to 0. They are saying are equal and opposite. So if we have got two roots which are equal and opposite, that means that if the first value is, say, take that the first value is positive a, then the other value is going to be negative a. That's the meaning. They are equal but opposite. So that means we had x minus a squared, sorry, not square, let me not put a squared, and then x plus a, and that was equal to 0. In other words, what we had is a difference of two squares. So a difference of two squares, if we expand this is going to give us x times x, that would be x squared minus a squared being equal to 0, a difference of two squares. So at this point, I'm going to make sure that even this equation which I have here, x squared is in 1, the coefficient of x squared is a 1. So I'll divide everything by a 3 in that manner, so that I'm going to have x squared plus k minus 1 over 3 minus 2 over 3, that is going to be equal to 0. So at this point, what we are saying is, okay, we have got this quadratic expression. We don't have x, we only have x squared and a constant. So that means it is x squared plus 0x and then minus a squared being equal to 0. So this portion is going to be equal to this, and then this is going to be equal to this, and then this is going to be equal to this. So my aim is just to find the value of k. So I'm going to say k minus 1 over 3 is going to be equal to 0. So this I'm going to find that k minus 1 is equal to 0, because if I cross multiply, I'm going to get a 0 there. So that means my k is equal to 1. So that is the value of k in that case. Alright, for the third one, so we've been given that the roots of the equation x squared plus 2 minus k x minus 2k is equal to 0. Alright, so we've been told that the roots are real and distinct. They are real and distinct. So what does it mean if the roots are real and distinct? So if they are real and distinct, that means b squared minus 4ac is going to be greater than 0. That is the condition that we already stated. Okay, so we are going to say b squared minus 4ac is greater than 0. Now our b in this case, we are going to say 2 minus k. So that is our b, the number in front of x. So squared, and then minus 4. Our a is the number in front of x, which is simply a 1. And then times c, the constant, which is negative 2k, and that should be greater than 0. So if we expand this, 2 minus k squared, that is going to give us 4 minus 4k, and then plus k squared. If we multiply negative 4 by negative 2k, we are going to get positive 8k, and that is going to be greater than 0. So I can add this and this, so we are going to have k squared negative 4k plus 8k, that would be positive 4k, and then plus 4, which is there, and that should be greater than 0. Now at this point, I can look for two numbers which I can multiply to get 4 and add to get 4 again. So that would be 2 and 2. So this is the same as k squared plus 2k plus 2k plus 4, which is greater than 0, which I can also write as k, open brackets, k plus 2. I'm going to factorize the first 2, and then plus 2k plus 2 again. That is going to be greater than 0. So what you are having here is, I can get this and this and put them together. So that will be k plus 2, and then the other portion also we have got k plus 2, so that is greater than 0. So what I'm finding here, I've got two values which are the same. So I'm finding that anyway, let me take that k, let me say this was an equal sign. So if we say that was an equal sign, then we would find that k is equal to 2, or k is equal to, sorry, k is equal to negative 2, or k is equal to negative 2, in that manner. Now we found these two values as the values of k. So what are we going to do? Because we don't want to find the value as equal to, this is greater than, and we don't need to have an equal to. So we are going to get a number line and put those two values that we have found. But notice that even if they look like two values, this is simply one value, that's just negative 2. So I'm going to write first the first factor, which is the k plus 2. I'm also going to write the second factor, which is the k plus 2. Now what happens if I get any value of x which is above negative 2? I can get a number such as a 0. A 0 is above negative 2. So let me put a number above negative 2 here. So it will be 0 plus 2. What I'm finding is a positive value, is a 2. Even here same, it will be positive 2. I'll put here. Now what happens if I get any number smaller than negative 2, such as a negative 3? So if I put negative 3, it will be negative 3 plus 2, which is a negative value. Same here, to be a negative value. But remember, we are multiplying these two values, so we are interested in the product. So negative times negative, what we are going to get is positive. And then positive times positive, what we are going to get is positive. Now remember, our expression is saying the product of those two should be greater than 0. Now greater than 0 means our value should be a positive value, and we can see that for whatsoever value that we are going to get, whatsoever value of k, our product is going to be what? Positive. That means k is going to be any real number. That's the meaning. So k can be anything. It can either be above negative 2 or below negative 2, but note, it shouldn't be negative 2 itself. Why? Because we want this value should be real and distinct. If it is going to be negative 2 itself, then the two values are going to be the same. As you can see, it is negative 2 and negative 2. So therefore, we are going to conclude as okay. So we are going to say our k is any real number. So I can write it in two forms. K is a member of real numbers. So I can say such that k is not equal to negative 2. I can write it like this, or I can say this k is coming from negative infinity up to negative 2, and then at negative 2 we are going to pause, and then from negative 2 up to infinity. So I can also give it in that form. So any of these two forms. Alright.